other ones on the other side. Okay, so it's not symmetric, right? You kind of have two sides to this guy. And so when we're looking at it for polarity, hydrogen is more positive because it has a lower electronegativity. Oxygen is more negative because it has a higher electronegativity. So the water molecule is polar because the hydrogen side is more positive and the oxygen side is more negative. See that minus sign right there? That was your cue to say negative. Let's try it again. The hydrogen side is more
Positive.
positive. The oxygen side is more
Negative.
Thank you. Back row, I see you. Yes.
Is water magnetic then?
Polar. It's polar.
Oh, well, like if I put it, well, because if it has positives on one side and negatives on the other side, it's like.
So that is a question for physics class. Magnetic energy and charge are related but different.
Attractive, but not.
So just because you have a magnet doesn't necessarily mean that charges will flow in a certain way. Did we cover that? We didn't get to E and F, did we? All right, hey guys, whenever you're ready to join us, that would be awesome. So if you have a bunch of polar molecules together, they tend to fit nicely within each other, right? As they orient themselves together, you're going to have, sorry, I was looking in class. You're going to have the positive side of the sodium chloride kind of hang out over here on the negative side of the water, and then the opposing negative side will then orient itself around other water molecules so that this will be near the positive side. So you can see that they would fit together well. Hence, when we pour water into like salt, it usually dissolves because the salt molecules and the water molecules fit well together. One more thing that you should know, you know, when you're like disappointed that you erased something, like the second you erase it, is that we will generally, instead of just drawing pluses and minuses, we will generally draw arrows to denote the direction of positive. So those arrows will look something like this. You'll draw a plus sign at the positive side and then draw the arrow to the negative. Okay. So for this polar molecule, positive is over here and it goes negative that way. This guy, positive is here and negative is that way. For this guy, I would draw no arrow because O2 is non-polar. Sound good? Maybe? Alright, so it seems like we need, what's up? This guy, non-polar.
Yeah, I thought you said it was polar.
I wrote non-polar right.
I got
you. You're like, okay. Let's do a quick review of the geometries really quickly because I think we need it. Before we move on. So, let's pick some random numbers here. How many geometries are there?
There's the T1,
Great. There's like, well, let's see, 2, 4, 6, 8. All right. I think that's an animal. Where did you get that?
They're right small, so it looks like that.
Okay, so all right, your job is to fill in the chart. Cool. There's no such thing as one electron. No, this is just for now. for the wake up call. Alright, what do I want? 4, 4, 3, 2, 1. I want 3, 3, 2. And I want 2, 2. Right? 2, 4, 5, 6, 7, 4, 5, 6, 7, 8. Alright, so fill out the geometry for these as a quick refresher. Yeah.
Underneath the double fours, is that a 7 or 2?
There are no sevens. So it must be. So remember, the number of electron regions is the number of, if you take your central atom, how many sets of electrons does it have coming off of it? So this includes bonds and this includes pairs of electrons. This is the number of bonds that are coming off of it. So number of different atoms that you're linking to.
Just so I can get the
I mean, it's in your notes because we did the table last week.
I was here. You were here. You said excuse me.
It didn't work for you so well last time.
Is that a 2 or a question mark?
So try and do it without looking at the answers in the book, if possible. Just see how much you remember.
I can't know something that I don't know. Wait, do we even get like an equation out of it at least?
No. So you should be able to figure it out. This is how I would attempt to figure it out, because I don't have them memorized either. Because ain't nobody got room in their brain for that. So let's look at this one right here. So if I have an atom in the middle, and then I have 3 electron regions, but only 2 bonds, I probably have electrons there, and then 2 bonds. What's that going to look like?
A bent thing.
Probably going to look bent. There's only one pair of electrons pushing, so it'll probably be the 120.
I don't think so.
Oh.
Because these electrons are going to push those guys down.
But why is it bent? Because it's the bent shape thing?
Because these guys are pushing these positive protons away.
So it's called bent because it looks bent?
Because it is bent. Yes. The names attempt to describe the geometry. Otherwise, they would name them something else. It's on your table. Yes.
Did you ever go through
All of them? Yes.
no, but the electron region of 2? Because I remember only going through 4 and 3.
Yeah, 2 is really confusing. So draw a picture if you don't like.
Oh wait, no, I have the ring.
Yeah.
I see.
Well, you need to get the ring. Oh. Or attempt to remember the ring. Those are all red. Go home.
Oh. So we're in captivity right now?
Yep.
Oh, especially when the heat is. Do You guys write the whole chart out, or can you just write the answer? Like,
Write the whole chart out. Then when you come to me next week and I say it's in your notes, and you're gonna be like, and then I'm gonna be like, check your notes, and then you're gonna be like, okay, so that one's bent. Let's go to the next one. You have 4 electron regions, but 2 bonds. 2 bonds is probably gonna look like this. Now you have 4 electron regions. So that's that guy. Here, reason with me, everybody. Up here, up here, up here. I'll hold. Welcome home. That's the whole music for this school. I play it for Gabby because she put me on hold one time. I put my boss on hold one time. Not here. It's not a good thing. Don't ever do that. Just keep talking. Just keep talking. Always keep talking. Sure, I'll get someone to figure that out for you. And then you just keep talking. So how's your day? How's the weather up there in Phoenix? Oh, it's great. I'm so glad to hear that. Yeah? Yeah, how's the whole being a CEO thing going? Oh, great. Oh, awesome. Me too. Yeah, being a lowly intern is amazing. All right, and you just keep going. Okay, this one's bent. 92 degrees. Okay, 2 and 1. You have 2 electron regions. You probably have, this is it. Right? 1 bond, 2 electron regions. So this is linear. In fact, anytime you only have 1 bond, it has to be linear. Now you have 3 and 3. So you have your central atom here. You have 3 electron regions, but they're all bonds.
Is that last one 4 too?
Yeah.
So what is this one? There's 3 things. So trigonal, planar. I very possibly might have done that. Which one did I do, Troy?
That's what it should be. No, you removed that one. Yes, he did.
1,
There's
2,
4.
3. Thank you all. Thank you all. All right, next. 4 and 3. So you have 4 electron regions, but only 3 bonds coming up. So you have a guy in the middle, right? And you have 1 pair, and then you have 3 things coming off of it. So what does that kind of look like? It's a pyramid. Okay, what's the difference between this one and that one? This one has these 2 electrons on top, which basically bully all the rest of them into going down. Okay, here, there's no such thing, so they can stay in a straight, plane.
Wait.
Yes.
Why are they scared of 2 people?
Because these are all positively charged.
Good.
The protons are all positive. And so if you have these 2 electrons hanging out up here, it's going to push everything else down.
They could hang up and down. Yeah, there's 3 dudes.
Moving on. So 2 and 2. So you have 2 electron regions, but those are all caught up in the 2 bond regions. So you have a double bond here and a double bond here to something else. That's going to be linear. Why? Because there's nothing pushing like down at all, because there's no electrons there. If there were electrons there, then there would be 3 electron regions. There's not. There's only 2. Okay. Finally, 4 and 4 is the tetrahedral. Tetrahedral. So you have 1 on top, you have 3 on bottom, and then you have your central atom. Okay, so that's our table. We'll talk about which ones can be polar and which ones will never be polar after this short commercial break. Your homework is
1 hour still left.
Ooh, should I?
Should you?
No,
All right, we'll just do number 13 on page 188. And then we'll do 14 in class.